All right, so today I'm going to show you how to write formulas for ionic compounds. So remember, ionic compounds happen when you have a metal that loses electrons and a nonmetal that gains electrons. So the metal becomes a cation and the nonmetal becomes an anion. And ionic compounds have names like aluminum chloride. All right, now to do these formulas, you are going to need to know the charges of the different elements on the periodic table. So I'm going to grab a periodic table. We've learned this before, so this is just a review. Remember, everything in the first column forms a +1 ion because it loses one valence electron. Everything in the second column forms a +2 ion. We skip over the transition metals. They form positive ions, but we don't know exactly what charge. This third column forms +3. We skip over this column. They don't really form ions. And then this column is -3, -2, and -1. And then these ones don't have a charge over here. So we need to look and see what charge aluminum has on the periodic table. Aluminum is a 3+. So I'm going to write down, I'm going to make a table to balance aluminum chloride. I'm just going to divide my compound in half, basically. So I've got aluminum 3+, because it's a +3, and then chloride is the same thing as chlorine. We just change the ending to "ide" when it becomes an ion. So you're going to look for chlorine, which has become chloride because it's become a -1. So we're going to write down Cl-. You don't really need to write the 1. If you just write a negative or a positive, we assume it's a 1. So usually when people write ions, they don't write 1-, they just write minus. Now, when we are making formulas for ionic compounds, our goal is to get the charges to be balanced. So basically, for every positive charge over here on the left, there has to be the same number of negative charges over here on the right. So right now, there's 3 positives and 1 negative. So I need to make it so there's 3 positives and 3 negatives. So the only way I can do that is by adding more chlorides. So basically, when aluminum and chloride bond together, when they attract, we're going to need more than 1 chloride to attract to the aluminum. So if I add another chloride, now I've got -2 over here and +3 over here. And if I add a third chloride, now I've got -3 on this side and +3 on this side. So they're balanced. And then to write the formula, I don't write the charge, so don't write the charges in the formula. I just write the symbol of the element, and then I write a subscript for how many there are of that element. If there's just 1, then I don't even write a subscript. So Al is just 1, but there's 3 chlorides. So I'm going to write a little 3. So it's AlCl3. Okay, let's try another one. Let's try... trying to think what a good one would be. Let's do calcium nitride. Okay, so if we look over here, calcium is in the +2 column. So it's a +2. And then nitride is the same thing as nitrogen. So it's over here in the -3 column. So this is a little bit trickier to balance, but it can be done. As you can see, I am going to have to add more of both of these to balance this. We're kind of looking for a common multiple. So we're going to want these both to multiply to 6. So if I add another nitrogen, if I add up these 2, 3 negatives, that gives me 6 negatives on this side. Remember, I need there to be the same number of positives as there are negatives. So I need to add 2 more calciums. So that gives me 6 positive on this side, 6 negative on this side. I used 3 calcium, so I'm going to do Ca3 and 2. Okay, last example, I'm going to do a transition metal example. So let's do iron, and then we're going to do Roman numeral 3 oxide. Okay, this is actually rust. This is the chemical formula for rust. So if we look at iron on the periodic table, it's in this middle section. We don't know what its charge is, but it has these lines. This is the Roman numeral 3. So you do need to know your Roman numerals, but only the 1 through 3. So you guys know Roman numeral 1 is 1 line, Roman numeral 2 is 2 lines, and 3 is 3 lines. That's all you need to know. Okay? So that Roman numeral 3 tells us the charge of the iron. Doesn't tell us there's 3 irons. It tells us the iron is a 3+. And we need those Roman numerals because since it's right here on the periodic table, we don't know what charge it has. But we can look up oxide, which is the ion form of oxygen, which is a -2. So this is going to be kind of like the one before, where I'm going to need a couple of irons to make this 6 positive over here, and 2 more oxygens to make this 6 negative. So it's going to be Fe2O3. All right, so that's how you write formulas of ionic compounds.